Good morning, kids. Today we're going to talk about a different type of slope field, basically. It's a slope field that we do algebraically. It's called Euler's method, and it's a chart that takes you through the steps of a function. So the things you will need are this sheet that I gave you last class, or Mr. Sedita gave you last class, your notebook, and also in the Calc 2 drawer there's a big thick packet that is pages from an old book that we're going to use for the slope field homework. So take that out as well. So Euler's method is a chart form of a slope field. So we find our new approximate y value for a differential equation by adding y prime times delta x. Now we're going to be given a formula for y prime, and we're either going to be given a delta x or we're going to figure out what delta x is based on endpoints and the number of subdivisions. So we add that y prime delta x to our old y value and we get our new y value because of this. Since y prime is equal to delta y over delta x, the change in y over the change in x, that means that if you multiply both sides by delta x, you can get, if you take y prime times delta x, you will get the change in y. What do you want to do with the change in y? Well, you multiply it, or excuse me, you add it to the old y to get a new y value. So to find out what to use for delta x in Euler's method, if it's not given to you, you take your new x minus your old x divided by the number of steps or the number of subdivisions, or they may just call it n. All right? You use that formula to find delta x. Now delta x is just the steps that you use to get from your old x to your new x. So let me show you what a chart would look like. Basically you're going to have x, you're going to have y, you're going to have y prime, which you will use a formula to get, and then you'll have delta y. Now your initial value will be given to you, so you'll fill in these two values, and then everything else you'll get by using your formula to get y prime, finding delta y by doing y prime times delta x, which is going to be a set value, and then you add your delta y to your old y in order to get a new y. All right, and you do those same steps until you get to an answer. So this is so simple a small child can do it. I'm not sure if Mary could do it yet, but I'm pretty sure that Robbie could do it if he had to. Well, maybe not. Anyways, this shouldn't be a struggle for you guys. Once you get into the groove of it, it's actually quite monotonous. Now, two important things. The error in Euler's method is always proportional to 1 over the number of steps used. And then second of all, if the graph of a function is concave up, the estimate will always be an underestimate. And if the graph is concave down, the estimate will be an overestimate. And that should make sense because if you have a concave up graph, your slopes will go under it. And if you have a concave down graph, your slopes of the graph will end up going over it. So that's why. All right, so let's go to the first problem, page 534, and this is, I believe, in that packet. Now, I could be wrong, it could be in your book, but I think there's a big thick packet that is in the Calc 2 drawer, and if you go to page 534 of that packet, which should be right near the beginning, and look at number 1, it says the following. It'll give you y prime equals x plus y. It gives you delta x equals 0.1. And it says find y when x equals 0.4. So the first thing you do is you fill in your y0. You're given that y of 0 equals 1 in the first part. So that means that when x is 0, y is 1. Next thing you do is you fill in your x column. Now your x is going to go up by steps of 0.1, and you stop when you reach 0.4. All right, so 0, 0.1, 0.2, 0.3, 0.4, and that is your y column, or your x column, excuse me. Now, to get your y prime, you just use whatever the formula is. Now, the formula for this particular problem is y prime equals x plus y. So I'm going to write that up here. Y prime equals x plus y. So what you're going to do to find your y prime is add your x and y. So in this case, it's going to be 0 plus 1. I won't always show that work, but I'm going to for this first problem. 0 plus 1 equals 1. And then delta y is y prime times delta x, right? Every single time delta y will be y prime, whatever you got in the column before, times delta x, which in this particular case is 0.1. So delta y is y prime times 0.1. So here delta y will equal y prime, which is 1 from the column before, times 0.1. So that gives you 0.1. Now, to get your new y, okay, so we're taking this, we're going to add it to our old y to get our new y. So 1 plus 0.1 equals 1.1. All right, so now what are we going to do next? Well, we're going to find y prime again. Now this time we have a different x, a different y, so we're going to have a different y prime. Y prime is equal to x, which is 0.1, plus y, which is 1.1. So I get 1.2. And then to get delta y, again, I'm going to do y prime times 0.1. So I do 1.2 times 0.1, and I get 0.12. What's next? Well, I take that and I add it to my old y. So I come back over here, I add it to this. Okay, so when I add it to 1.1, I say 1.1 plus 0.12 is equal to 1.22. And then to get my y prime, I'm going to do my x plus my y, so that's going to be 0.2 plus 1.22. And that turns out to be 1.42. And then to get my new delta y, I'm going to take that 1.42, oops, and I'm going to multiply it by 0.1, and I get 0.142. Okay, I'm not going to show the addition anymore. I think you guys probably are going to get it, at least in this step here. I'm not going to show the addition anymore. So we bring this 1.42 over and we add it to our old, or 0.142, excuse me, and we add it to our old, and what we get when we add 1.22 plus 0.142 is we get 1.362. Now we're going to add that to our x, so we do 0.3 plus 1.362, and we get 1.662. And then we take 1.662 times 0.1. You should be seeing a pattern at this point. I don't like that that line is blue. I wanted to make it pink. I'm going to fix it right now. I know, a little bit too OCD, but not too bad. All right, so then when we multiply that by 0.1, we get 0.1662. And then we're going to take that and we're going to add it to the 1.362 from the step before. So we say 1.362 plus 0.1662, and we get an answer of 1.5282. And that is our estimate when y of 0 equals 1, y prime is x plus y, and delta x is 0.1. It's basically where a slope field would take you if you knew what the points were on the slope field. Okay, so this is all these little, all those little lines on your slope field are basically representations of what's in this table. So now I'm going to move on to another problem. I'm only doing part A of this problem. I'm going to go to, oh no, I guess I'm going to do 1B as well. All right, so 1B, we need a big table for. Okay, so you have y prime is equal to x plus y. Delta x is 0.1. We're still going to estimate y of 0.4. And we're going to say y of -1 equals 0. So our initial condition is at -1. So -1, 0 is our first point. Okay? And then y prime equals x plus y. So when we add those two things together, -1 plus 0, we get -1. Okay, so you could almost go through and just put pluses between these. This plus this equals this in this particular problem. Not in every problem, but in this particular problem. And then delta y is equal to y prime times 0.1. So y prime here is -1, so it's -1 times 0.1, which gives you -0.1. Now you're going to come over and you're going to add that to your old y. So you take -0.1 plus 0, and we get -1.1 plus 0 is -0.1. And then check it out. Y prime is equal to x plus y. So check it out. -0.9 plus -0.1 is -1. And then y prime times delta x gives you delta y. So now we're going to take our negative, whoa, just lost it. Hold on. We're going to take our -0.1 times our 0.1, and again we get -0.1. So now we have a -0.1. To get our new y, remember, we take and we add it to our old y. We're always taking it and adding it to that. So if we take -0.1 plus -0.1, check it out, we get -0.2. And then when we add to get our y prime, x plus y gives us, again, -1. So at this point you're like, this looks interesting. It looks like there could be a pattern. So let's keep going, see if it follows. I'm going to follow it for a little while just to make sure that it is in fact a pattern. So now we're going to take our y prime times 0.1. Again, we're going to get -0.1, same answer because it's the same values. We take that -0.1, we add it to -0.2, and boom, we get -0.3. -0.3 plus -0.7 gives us -1. -1 times 0.1 gives us -0.1, and again it's going to follow. So at this point I'm fairly secure that this is going to happen all the way up to 0. Sometimes when you get to 0 it throws a wrench in the works. Okay, so what I'm going to do is I'm going to follow this pattern as far as 0, and then when I get down to 0 I'm going to check to make sure that it's still going to work at 0. So I can pretty much assume that this is going to be -0.4, -0.5, -0.6, -0.7, -0.8, -0.9. All these will turn out to be -1. All these will turn out to be -0.1. But 0 makes me nervous because it doesn't behave like other numbers sometimes. So we're going to check and make sure that it still follows when we get to 0. So when we get to 0, we're going to take our old, we're going to take our y prime, or excuse me, our delta y, and we're going to add it to our old y. So when we do that, take our delta y, we add it to our old y, and we get -1. Well, 0 plus -1 gives us -1, and then -1 times 0.1 will give us -0.1. And then again we go back, we add the -0.1 to the -1, and we get -1.1. We add that to 0.1, and guess what? Again, we get -1. And then we multiply that, we get -0.1. And guess what? The pattern appears to be continuing. So the next one is going to be -1.2, -1.3, -1.4. Now, if it says use Euler's method, you must fill in the table. So let's fill in the rest of the table. But it sure helps not to have to do much brain work here. Once you establish the pattern, just go ahead and make it happen. So there you go. So what is the answer? Y of 0.4 is equal to -1.4. That's your answer, 2(1)B. Moving on, let's look at 5. Number 5, I think it's the last one I'm going to be doing. I'm not positive, but yep. We're going to do 5 together, and then we're going to be finished. So this one says dy dx, y prime, same thing, right, is equal to 2x. And then y of 0 is 1. And we're going to use 2 steps. So this time you are not given delta x. But it's easy to find, right? Because you are given a value at 0. And so your old y, let me use a different color here. Your old y is equal to 0. Your new y that you want the answer for is equal to, not y, I mean x, excuse me. Your old x, Slack-Joles, you've been out of the classroom too long, you must be losing it. All right, old x is 0. New x is, well, it's what you want to find the y for, so 1, right? So the formula says you basically do delta x equals your new x minus your old x divided by n, right? So delta x equals new minus old over n. So that's going to be 1 minus 0 over 2, right? Because it's 2 steps, n equals 2. So it's going to be 0.5. So this is going to be very quick because you're going up by steps of 1.5. You got to get to 1. So we start at 0, and then our next value will be 0.5, and our next value will be 1, and that, well, not 0.1, but 1. See, I told you I'm getting old. And we already have our initial value, y of 0 is 1, so we put 0, 1 in this column. And so all we have to do is get up to 1. Now y prime in this case is 2x. So we're going to double our x to get our y prime. Our y prime is completely not dependent on y at all. And then delta y is going to be equal to 0.5 delta x times whatever we get for y prime. So let's get going on this. Y prime is equal to 2x, so y prime for this first part is equal to 2 times 0, which of course is 0. And then delta y is equal to 0.5 times y prime, so that's 0.5 times 0, which is equal to 0. So now we're going to take that, we're going to add it to our old y to get our new y. So 0 plus 1 is equal to 1. All right, and then y prime is equal to 2 times x. So 2 times, I hear Mary, 0.5 is equal to 1. And then we're going to do delta y is 0.5 times y prime. So 0.5 times 1 gives us 0.5. And then to get our new y, we add to our old y. So we're going to do this 0.5 plus the 1 that's back there. So we get 1.5. So what is our estimate? Well, our estimate is y of 1 equals 1.5. Okay, there might be a small gap because I have to pause. Mary is not a happy camper. Let me pause for a minute and I'll be, there may be a little teeny gap. So little Mary is quite contrary in the morning. She is awake all morning long. So sometimes it's pretty tricky to do the videos. Sometimes I procrastinate, and that's never a good thing. But today I'm going to knock it out. So here we go. You guys don't know anything about procrastination, right? Wink, wink. All right, so moving on. Dy dx equals 2x. In part B, it asks us to actually find the actual value, all right, of of our differential equation so that we can actually find what y of 0 is for part C. So we're going to solve this differential equation in part B. It's a very simple one to solve. So first we'll separate the variables, multiply both sides by dx. So we'll get dy is equal to 2x dx, and this is really easy to solve. We integrate both sides, we get y equals x squared, because we add 1 to the exponent and then we flip it, multiply by 2, so we get x squared plus c. Now we'll use our initial condition in this in order to figure out what c is, right? So y of 0 is 1, that means x is 0, y is 1, so I get 1 equals 0 squared plus c, so 1 equals c. All right, so now I have 1 equal to c, and I take these two things and I put them together to get the solution to my differential equation, which is y equals x squared plus 1. Not having the book in front of me, I'm sort of guessing what the questions say. I forgot to bring this particular book home, but not a big deal. The next part says, I believe, something to the effect of, check out the error. Should say what the error is in the differential equation and show that the error is actually proportional to 1 over n. So that's what I'm going to do here in part C. So we know, first of all, using the differential equation, we can find the actual value for y of 1. So let me put c right here. We're going to use our actual solution. So y equals x squared plus 1. So y of 1 would equal 1 squared plus 1, which is equal to 2. Okay, so 2 is what our y of 1 is. That's the actual value of the differential equation. All right, so the error in this is when n equals 2, okay, when n is equal to 2. Oh, hold on. I'm not even going to pause this time. I'm just going to go over and she does not like to be left in the morning. Okay, so the error, but I can't do it at night because once Robbie's home from daycare, he needs my full attention because he doesn't like to have to go to daycare when Mommy's home. So going on to math, the error when n equals 2 would be equal to, well, we found the value for using Euler's method for n equals 2. It's 2 minus 1.5, which is equal to 0.5. Now, being the lazy math teacher that I am, I'm not going to tell you, or I'm not going to do the Euler's method to use 4 steps, but you can take my word for it that Euler's method 4 steps would give you y of 1 equals 1.75. And I didn't do work for that. All right, so I'm just pulling that one out of my posterior region, if you will. Okay, so 4 steps, y of 1 is 1.75. You could do that, but I'm just going to skip that, and you can take my word for it. So the error when n equals 4 would be 2 minus 1.75, which would equal 0.25. All right, so that's the error, right? The error is the difference between the actual value and what your estimate is. All right, so those are the two error values. Now, let's see if this is proportional based on the number of steps. All right, so let's make a proportion. So the error is proportional to, so equals k times 1 over n. So if we were to solve for k, we should find the constant of proportionality. So let's go ahead and do that. So our error for n equals 2 was 0.5. Okay, so let's, when n equals 2, the error is 0.5, and that's equal to k times 1 over 2. Well, if I solve that, I divide both sides by 0.5, and I get k equals 1. So our constant of proportionality is 1. So now I can fill that in, you see, into our formula. So if I take this constant of proportionality and fill it in here, I get the proportion that this should hold true to. So E equals 1 times 1 over n. So let's see if that holds true for the other calculation. So now I'm going to plug these in and see if it holds true. So if I plug in the values for when n equals 4, all right, well, what is the error when n equals 4? The error is 0.25. So I say 0.25 is equal to 1, which was our constant of proportionality, times 1/4. And I get 0.25 equals 0.25. And sure enough, it does work. K is 1 for both things. So yes, it does work, the error formula. The error is proportional to the number of steps, and we've shown that for this problem. All right, so your homework is in that packet. It's 534 to 535. It's very deceiving because it takes some time to do these problems. Numbers 4a, 6, 7a, and 9. Now the problems are very simple, but they are a bit monotonous, so I do apologize for that. Good luck on those, and have a fabulous day. Bye-bye.